This podcast is generated by AI from the most interesting articles selected by the AI Security Foundation experts. Welcome back to the Deep Dive. Today, our mission is really to give you a shortcut, a way to understand what's happening at the absolute cutting edge of AI in late 2025. We've got a great stack of sources that, well, they seem to tell a pretty unified story. This is the year autonomous AI agents stop being just research ideas. They're starting to become critical infrastructure.
That shift exactly, going from prototype to, production scale, that's really the focus of everything we've pulled together for you today. And it creates this fascinating split, really. On one side, you see this just unprecedented power, specialized capabilities emerging. But on the other, the systemic risks are, well, they're staggering, especially when these agents operate autonomously out in the real world in untrusted environments. We've sort of hit this point where the potential and the danger, they're rising at the exact same speed. It's quite something.
Right, so we've tried to structure this deep dive around those tensions. We're going to cover three critical areas for you. First up, we're unpacking the sort of hidden security dangers, the architectural ones, baked into these autonomous browsing agents. Second, we'll look at the flip side, the incredible power coming from highly specialized AI. Think foundational math, but also enterprise cybersecurity. And finally, we pivot to the regulatory side. There's this growing push in Europe to maybe simplify GDPR to actually accommodate all this AI growth.
Yeah, it's a conversation that really defines where we are in 2025. So let's just jump right in, maybe with that biggest immediate worry, the fragility of these browsing agents.
Okay, let's unpack this core security problem then. We're talking about these powerful LLM-powered agents, right? The ones being deployed more and more to handle really complex real-world stuff. Things like, automatically booking complex travel, maybe managing your email inbox autonomously.
Exactly. And they do this on the live internet, which, as our sources make really clear, opens up this massive and frankly poorly understood attack surface.
And the fragility isn't just like a bug, is it? It sounds structural.
It is structural, yes. It's baked into the design. These browsing agents, they have to operate in what the researchers call a sense-reason-act loop. So first, they sense the environment. That means injecting dynamic, untrusted web content. And crucially, this isn't just the text you or I would read.
Okay, what else is there?
It includes things like screenshots, the state of buttons on a page, and the underlying document object model structure, the DOM.
Right, let's pause there. DOM structure. What exactly is that, and why is it so important for the agent and maybe the attacker?
Okay, think of the DOM as the web page's invisible blueprint. You see the layout, the text, the pictures. The agent, though, it also sees the entire backend code structure that defines how all those visible elements relate to each other, how they're organized. And it has to ingest this external untrusted content. That's the key. That outside data directly influences its reasoning and ultimately what actions it takes. Okay. So if it's taking in untrusted web content to make decisions, the attacker just needs to hide a malicious instruction, maybe a prompt, somewhere on the page, somewhere a human might not notice, but the agent's perception system picks it up and treats it as, a legitimate command. Is that the core vulnerability?
That's precisely it. And the research we looked at provides the first really comprehensive full-stack threat model for these agents. It confirms critical vulnerabilities across multiple layers of the architecture. We're talking perception, reasoning, planning, even the external tools the agent uses.
So it's not just the LLM messing up.
No, exactly. The key insight here is that the danger isn't just the LLM's reasoning capability failing, it's the entire agent stack that's exposed.
And this is where it gets really concrete, isn't it? The sources talk about an alarming proof of concept. They actually built a working exploit, demonstrated how a malicious web page could successfully hijack the agent's behavior.
Yeah, make it do things like extract stored credentials or perform unauthorized actions on behalf of the user. That's terrifying. A single visit to a compromised website could potentially lead to a full compromise of a highly privileged agent.
And it wasn't theoretical. They showed it working, using two key methods they found. One was prompt injection, like you said, embedded right into the web page content, hidden in, say, a button name or description field the user might ignore.
Okay, what was the other one?
The other was a domain validation bypass, basically tricking the agent into going to an attacker-controlled page, even when there were supposed to be security checks to prevent that.
But hang on, if the LLM is so sophisticated, shouldn't it be able to tell that, an instruction hidden in a link's text isn't the same as a real command from the user.
You'd think so, but that's the critical point the researchers are making. The agent relies on these untrusted inputs to sense the world and figure out what to do next. So the risk isn't just the LLM getting fooled, the security weaknesses run through the whole system. They use this framework called Maestro, and it confirmed risks across, I think, 7 different layers of the agent ecosystem.
7 layers, like what?
Yep. Everything from the tool registries it uses, the sandboxes it runs in, all the way down to the infrastructure itself. If the agent's own tools can be tricked or compromised, the LLM's security becomes kind of irrelevant.
Okay, so what's the big takeaway here for, the learner listening, for organizations thinking about actually using these agents in production?
Well, the main thing is you absolutely cannot rely on traditional web security practices alone. It's not enough.
Because the agent acts like,
Yeah.
what, an autonomous browser?
Exactly. An autonomous browser with potentially huge privileges, but without the built-in maturity or guardrails we take for granted in normal browsers.
So defense then. If the problem is structural, can we just retrain the LLM to filter out bad prompts? Or is it more complicated?
The sources argue it's much more complicated. You need a robust, defense-in-depth strategy. No single layer is going to be enough.
Okay, lay out those necessary guardrails for us. What do people need to be building?
Right. First, input sanitization. You have to clean up that untrusted web content before it even reaches the reasoning layer. Makes sense. Second, LLM-based anomaly detection, trying to spot when the agent plans to do something weird or unexpected.
Okay.
But probably the most crucial structural step is strict planner-executor isolation and session isolation, too.
Planner-executor isolation, what does that mean?
It means you can't let the part of the agent that decides what to do, the planner, be too tightly coupled, too interconnected with the part that actually does it, the executor.
Ah, you need a gap, a firewall between thinking and doing.
Precisely. You need those multiple layers of protection if you want these incredibly powerful agents to be anywhere near safe enough for real production use cases.
Okay, so if these general models, the browsing agents, are this structurally unstable and need such complex isolation, it really does make sense that the real power, the reliable power, is maybe emerging only in highly constrained specialized areas.
It's a stark contrast, isn't it?
Yeah. So let's look at those focused applications, starting with what sounds like a genuine scientific breakthrough.
Yes, our first example here comes from Google DeepMind, a system called AlphaEvolve. And the interesting thing is, this system doesn't just automate complex things we already know how to do. It aims to be a true scientific collaborator. Its goal is solving problems that until now were basically considered mathematically intractable, unsolved.
Okay, how does AlphaEvolve work then? How is it different from just a big LLM searching a massive database for the best non-answer?
It combines LLM reasoning, which is good at understanding context, with something called evolutionary search.
Evolutionary search.
Yeah, think of it like this. A standard LLM is like a brilliant student reading all the textbooks ever written. AlphaEvolve, instead, sets up millions of digital labs all at once. It forces different code snippets and algorithmic variations to compete, mutate, evolve, trying out totally new approaches until a better solution emerges.
So it's not just finding existing solutions, it's generating novel ones.
Yeah, exactly. Its job is tackling genuinely unsolved mathematical problems or complex algorithm design tasks, like finding fundamentally more efficient ways to do matrix multiplication, which is core to so much computing.
Wow, that really does sound like a fundamental shift. Moving AI from just doing tasks to actively inventing solutions.
It does. It suggests we might see an acceleration in foundational research, math, computer science, that could be completely unprecedented.
Okay, so that's abstract science. Now, contrast that with something very concrete, very high stakes, enterprise security. This brings us to Cisco's new project.
A very different application, but similar principles of specialized power.
Right. This is Cisco building a massive new security AI model, set to exceed 17 billion parameters, I read. That's more than double their previous one.
It is. And in a world kind of obsessed with general-purpose LLMs getting bigger and bigger, this kind of scaling in a specialized domain, it's a really strong signal.
But it's not just the size, is it? It's the data.
That's the crucial part. The scaling is significant, sure, but what makes it truly powerful is the depth of the specialized training data. This model is being fed 30 years of proprietary threat intelligence harvested from Cisco Talos, their long-running security research group.
30 years?
Yeah, that depth of curated real-world security data, You just can't replicate that quickly. It's a huge moat.
And the function is changing too, right? It's not just detection anymore.
Exactly. Our source highlights that, unlike the models that came before it, this new one isn't just designed to spot threats, it's designed to provide actionable remediation recommendations.
So it tells you what to do about the threat.
Precisely. Moving from just alerts to actual prescriptive action. That's the key differentiator you need for high-stakes enterprise defense.
So if we connect this back, the message seems to be scale the model size, yes, but couple it with extremely specialized, high-quality, probably proprietary data. That's the path for AI in really critical fields like cybersecurity.
Absolutely. These models are highly constrained by their domain, by their specific task, and that constraint makes them far more reliable, far less unpredictable than the general-purpose browsing agents we started with.
Okay, so incredibly fragile general agents, but incredibly powerful specialized models driving breakthroughs in science and security. This huge surge in capability inevitably raises the question, how does regulation, specifically European regulation like GDPR, keep pace, without just slamming the brakes on all this innovation?
And that's the pivot into the political arena where you can really feel the tension. Germany, back in October 2025, submitted this 19-page proposal calling for pretty sweeping amendments to GDPR. And this proposal, it reflects a very real strategic effort trying to balance fundamental data rights with, well, enabling the speed of AI development.
Okay, what are the immediate things they're pushing for? The short-term reforms, I think they call it the digital omnibuses package.
That's the one. In the short term, it's mostly about simplification and clarification. Like simplifying the information requirements under Articles 13 and 14. Those are the rules about telling people clearly what data you collect and why.
How would they simplify that?
Maybe allowing companies to just use simple links or QR codes instead of forcing these incredibly dense, long text disclosures that, let's be honest, few people read.
Does simplifying compliance with a QR code really address the complexity of modern AI model training?
Yeah.
Or is that just kind of window dressing?
It's certainly an attempt to address the administrative burden, at least. Other key short-term ideas include extending the breach notification deadline.
Oh yeah, that's a tight one.
Very tight. From 72 hours, they're proposing maybe 3 full business days. Gives companies a bit more breathing room. They're also trying to clarify the rules around consent, Article 6. So that consent isn't automatically seen as the only or supreme lawful basis for processing data.
Acknowledging other reasons, like legitimate interest.
Exactly. Or contractual necessity. And finally, they want to limit what they term excessive data access requests.
The ones that can sometimes feel weaponized against compliance teams.
Those are the ones. They can impose a really significant burden, so those are the short-term fixes. But beyond that, the long-term goals seem focused on a deeper, more strategic realignment.
Like what?
They want a full review of GDPR's overall impact on Europe's competitiveness. How does it stack up? And seeking better alignment between privacy rules and the specific needs of AI innovation. They're even floating potential exemptions for low-risk processing or non-commercial research processing.
Oh, exemptions.
Yeah, basically acknowledging that training powerful AI often requires large data sets, and the current rules can really hinder that.
Wow. If those reforms actually get implemented, that would genuinely reshape Europe's whole regulatory landscape for tech.
It would. The outcome here will really define whether Europe manages to strike that balance fundamental rights versus the speed needed for AI adoption and training, or if they continue to lag behind places with maybe looser rules.
And the implementation timeline is key.
Absolutely. That will be the defining factor.
Okay, let's pull back now to the big picture. Try and tie these threads together. This transition to agent-driven transformation. It's not just theory anymore. It's happening right now. A recent McKinsey report seems to confirm this pretty strongly.
Yeah, the data's quite clear. Agent adoption is now significantly outpacing the use of just traditional LLMs. The report shows that the high performers, the leading companies, are twice as likely to be deploying agents broadly, across core use cases, too.
Like what kind of use cases?
High-volume workflow, automation, customer operations, and increasingly even software development itself.
This accelerated deployment brings us right back full circle to those systemic security risks we started with, the same report that cites this rapid adoption. It also highlights the major risks that are blocking companies from scaling these agents safely. It feels like the tech is moving faster than our ability to secure it.
That is the crucial cautionary link, isn't it? The specific architectural risks we talked about with browsing agents prompt injection, domain bypass, unintended actions. Those are directly related to the major risks McKinsey flags. Hallucinations, yes, but also severe data leakage and fundamental governance gaps.
And why are these risks so much higher for general agents compared to, say, that Cisco security model?
Because the general agents operate out in the open, in that untrusted environment, that makes them inherently susceptible to these unintended autonomous actions. Unless we fix that core architectural fragility across all 7 layers of the agent ecosystem that Mr. identified, those governance gaps, they'll be basically impossible to close properly at scale.
Right. Wow. Oh, okay. This has been quite a tour through the tensions defining AI in late 2025. We've seen the profound architectural fragility of these general autonomous agents, but also the focused, specialized power of systems like AlphaEvolve doing math discovery, or the Cisco Talos model for cybersecurity. And then the political will, at least in Europe, trying to reform regulations like GDPR to actually create space for all this explosive growth.
It's quite the landscape, and you see these highly specialized AI systems tackling everything from, complex math to enterprise cyber defense. Now, if you connect that capability back to the growing autonomy of the general agents, the very systems we know are exposed to these deep security flaws. It raises, I think, an important question for you, for the listener, to think about. As these AI agents become core parts of our critical infrastructure, what level of self-governance are we going to demand from them? I mean, will we eventually need AI systems maybe trained like Cisco's model on decades of security intelligence whose sole job is to analyze, enforce policy, and actually secure the complex legal and architectural layers of other autonomous agents? Is that the future? AI policing AI? It's something for you to maybe mull over or explore on your own?
A truly autonomous security agent watching over our autonomous browsing agents, that is definitely a future we need to start planning for right now. Thanks for joining us for the deep dive. We'll see you next time.